Well, I guess it's 10:45, so I think I'll get started with my portion. Okay, so hopefully you can see a whiteboard that I've pulled up here. Okay, so anyone know why I chose these numbers?
My phone number.
Today's date.
Today's date.
Date today.
Yes, it is today's date. So this will just give us a little bit of practice with numbers, number sense, operation sense, etc. What I'd like you to do is try to use these numbers in this order and make an equation. You can put the equal sign wherever you like between any of these numbers. You can use any of the 4 basic operations. You can use powers. But if you do use powers, you can't introduce numbers that are not already there. So if you wanted to do this, for example, so that could be 6 squared if you'd like to do that. You can use parentheses. You can also smush numbers together. So if you would like to think of this as a 36, you can do that. If you'd like to think of this as 362, you can do that. The fancy mathematical term for that, anybody know? When we put numbers actually together and think of it as a new 2-digit number or 3-digit number. The word I'm familiar with is concatenate. So that's a fancy term for smushing numbers together. Do you have questions about what you're allowed to do and what the object is?
Can we shuffle the numbers around?
No, Randy, you cannot change the order of the numbers. You have
Okay.
to leave the numbers as they are. Other questions?
Pam,
Yes.
can you restate that, please? Thank you.
All of the rules, Yolanda? Okay.
No, just the recent one.
Okay, you have to leave the numbers in this order. I'll just go through all of them one more time. You have to use the numbers in this order because it is today's date. And mixing them up would create a different date. You can use the 4 basic operations. You can use powers, parentheses, and you can concatenate numbers, as many as you like. If you want to think of this as 21 instead of a 2 and a 1, you are welcome to do that. And again, you can put your equal sign anywhere in here. So all you're trying to do is make an equation. Are there other questions about the rules or what the object is?
I have a question.
Okay.
Can I use absolute values?
Oh, I'm going to say yes. I wonder if you could do what you want to do with negative signs. I mean, you can, for example, if you want this 3 to be negative out here, you can just make it negative. So you can negate anything along the way. So you might be able to do what you want to do with a series of negative signs and parentheses. But if you think you need absolute values, then yes, I would say yes, go for it.
Excuse me, Miss Pamela, where can we send our answers?
I was going to maybe put us in breakout rooms at this
Oh.
point, and then
Okay.
we can share answers with the smaller group. So I'd like to sort of open this up to, now in my group, we had a question about what level, what grade level you could use this activity with. So I'd welcome people to chime in with their ideas about that. And also a great comment about, even with these numbers, and this is just one date that we chose, we could use whatever date we wanted to. There seem to be a lot of ways to make equations, a lot of creative ways. And that's, I think, one really nice thing about this activity. There's no one right or wrong answer. As long as you can make an equation that works, it works. So comments about what grade level we could use this for, and other comments about what are some good things about this activity, what are some limitations, could it be adjusted to be made easier, harder, what have you. So I'll just open up the floor for comments.
So this is Dwayne Yazzie. I noticed in our group, someone used, they used the number raised to the power of 0. So again, right there, that's something that's very higher thinking in terms of like middle school, high school. One said, oh, can I use absolute values? Again, that's something that's introduced a little bit later. So again, this could be something you could use it even as simple as, oh, hey, we're only using 2 of the operations. We're only using addition and subtraction. So it could be something very elementary, all the way up to something at the high school level.
Yeah, great comment, Dwayne. Yeah, it can really be used at a variety of levels. And just because a student does not know yet how to use powers or absolute value, it still could be a good activity for them. I see a comment about students might want to try their birth dates, and that would make it personally very interesting to them, I'm sure.
I noticed that one of somebody switched the 3 to a -3. Is that adding numbers? Is that breaking the rules? Is that acceptable?
I would say that's acceptable.
Okay, that's cool.
You could think of it, Randy, as multiplying that number by a -1, but I see what you mean. You might think of it as that's introducing something additional, but I would accept that. But you know, when you do it with students, you can obviously make your own rules, what's acceptable and what's not.
So Pam, this is Dwayne again. I've taught 4th and 5th grade and 6th grade, and I know I've attended one of your presentations before, and you talk a lot about number sense. And as a classroom teacher, yes, I know that you mentioned that, you know, this is something that kids really need to strengthen. And I absolutely agree that this is something that could be done, you know, once a day, at, you know, during some free time. Or at the beginning, you know, when kids are entering the room, to really build that sense of having a very strong sense of what number.
And even as you're trying to figure out an equation, you're doing a lot of computation in your heads, right? You're saying, oh, what if I divide these numbers? What if I concatenate these? What if I put the parentheses here? So you're doing lots and lots of calculating, even in the attempt to just come up with one equation. So imagine you have a whole classroom of students, And imagine all of the math calculation that's going on as they're trying to find an equation. So completely open-ended. And in my opinion, it's probably much more engaging than just giving them a worksheet of addition problems, multiplication problems to practice. Right, I see a comment from Ms. Begay about you can use significant historical dates that might have meaning to your students or meaning to your culture or something you're studying, something they might be studying in another class, a special date. Yeah. Any other comments on that activity? Yes, definitely order of operations. And to me, this activity is a really good one for students to develop that sense of why order of operations is important. Because they might want to make this equation work, and it's up to them to try to figure out how do I make this work? How do I indicate to someone else that I want this operation to be done before this operation? So they have to figure out, how do I use that order of operations to make my equation work?
Okay.
Okay, so I want to try to squeeze in 2 other activities in my time. So I'm going to now shift to a different one. Okay, so hopefully you're now seeing a puzzle from the Crazy Dad website. Can you all see something that's called Bridges by Crazy Dad? Okay. So those of you who were in the last workshop in January saw that I shared a different puzzle from the Crazy Dad website. So this one I don't think I've used in any Navajo Nation classroom visits. So I think this will be new for everybody. And the way I'm going to introduce this is I'm going to show you the picture of this particular puzzle already solved. So let me bring that up for you. So here is that puzzle solved. And I'm just going to ask you to see if you can notice some things about this solved puzzle so that we can try together to figure out what the rules are, in the spirit of Gord, who was with us in our last workshop. So I'll just open it up to you. What kinds of things do you notice? What do you think is going on? Why do you think this is a solved puzzle? What was the object? What do these things mean? So anything you notice.
Something I notice is that 1 always appears kind of at the end somewhere. Like there are 4 cases where 1 is at the end of a line by itself.
Okay, so if I heard you correctly, every time you see a 1, it seems to be like at the end of a line. Is that what you're saying?
Yeah,
Okay.
kind of like a dead end.
Or a
Nice.
starting point,
Say that again, please.
or could it be a starting point?
Could be, could be.
There's a 2 in almost every line that goes across, like in the corner, there's a 2. Then we go down 2, then there's another 2. So there's 2s, a lot of 2s where the lines are, where it connects to another number.
Okay. Did you say there are a lot of lines?
No, 2s, the number 2.
A lot of twos.
Like,
Oh,
like in 2 and then 2 and 3 and 2. And then
I think every
opposite
number,
side, 2, 4, 5, 3.
every number represents the connection to that number.
To the
How many numbers
line.
are connected
See,
to
like
it.
right there, there's 5 lines that are going into that 5 right there. There's 2 going up, 2 going to the right, and 1 coming down. When you go up to the 3 to the top of the page, there's 3 lines. There's 2 lines coming down and 1 line to the right. If you go to the 3 in the middle, there's 3 lines that go through that line.
Mm-hmm.
Nice. I see it now.
okay, excellent. Does everybody see that? So the number of
We
connections
see.
is the number in that circle. Nice. So I'm going to introduce some language just so it'll help us use the same terminology. I'm going to call each one of these circles an island, and then each one of the lines is a bridge. So you're trying to build bridges between all of these islands. Any other things that you're noticing about the bridges or about the islands?
They never overlap.
Oh, what do you mean by overlap?
Well, like, they don't go across the plane. I don't know. It's like this, they don't crisscross over one, and they don't have an intersection. It's like a roundabout. You drive and you go a roundabout and you can go into any other direction, but you can't go over another line.
Okay, yeah, excellent. So
There are
no,
no diagonals.
so no bridge is going over another bridge. I'm sorry, I didn't hear the last comment.
There are no diagonals.
Ah, thank you, Dwayne. Yeah, there, at least in this puzzle, there are no diagonals. All the bridges seem to be going across or up and down.
Looks like they're parallel to each other's.
Uh-huh.
It also looks like they're not on the same plane. Like if you were to turn this, the 3 might be at a 3rd level, the 2 might be at a 2nd level, and the 1 could be at a 1 level. You know, it could be 3. I mean, we're just looking at it from overhead.
Like
Maybe-
it could be a topographical map.
And yeah, it could be different points. The numbers are the different levels that it goes up and down.
Yeah, that's interesting. I guess we are looking at it from above, and it's not entirely clear if they're all in the same plane or not.
The bridges are all different sizes. I mean, length.
Huh.
There's a maximum of 2 bridges.
Maximum of 2.
The 2 bridges can be about connecting 2 numbers. We don't have any connected with 3 numbers or anything like that.
Right. Nice observation.
If we were gonna add and subtract them, the numbers on the islands, we could go both ways. We could subtract and add on the double lines. And maybe the one line is just the one way. So that could be a rule. If there's a 2-lane, then it might, you could use the, what is it called? Where you could add and subtract the numbers, and it will still add to the same, like 3 plus 2 is 2 plus 3.
Commutative,
Yeah,
property
commutative.
of
Okay,
addition.
yes, I'm in kindergarten, so I don't remember all the
That's fine.
terms. I just know that, we do introduce that, but not really hitting it. But that's what I see. I see a visual of that, where you can tell the student 5 and 3 make 8, and then going the other way, 3 or 5 minus. I can't explain it now. I lost the thought, but that's what I saw earlier.
Since we're talking about islands and bridges, could you say that the maximum amount of so the single bridges could be like road bridges, and the double bridge freeways?
Yeah.
Maybe you can tell the students that they can only have a road or a freeway connecting to the islands.
Sure.
So that way you don't have 3 lines coming out of sections.
Oh, I see what you mean. Yeah, so you'd
Yeah.
only have two-way traffic at the most.
Good way to explain it.
Okay. Now, there's one other thing. You guys have noticed most things I want you to notice, and those are in fact the rules, and I will summarize those in a second. There's one more thing I want you to notice. If I wanted to go from the upper right corner, this number 2, down to this 4 in the middle on the bottom, is there a path for me to do that? Can I get from that island to that island?
Yes.
Good.
And in fact, can I start at any island and get to any other island?
I don't think so. Some of them are bridges in at one point, but there's one that you can start from number 2 all the way to the left to 3, and then down to 2, and then across to the right to 3, and then that's the only one that will let you out. Enter right here on the right side at the bottom. Go all the way up 2, 3, 2, 2, 3, 3, 3, 5, 2, 3, and down.
Now, it occurs to me, maybe I've confused the issue by talking about two-way traffic. Just think of all of these bridges are, you can go back, you can go either direction on any bridge.
Right.
Okay. So don't be worried too much about which way you're going. But
They're all connected.
yeah. So the thing I want you to notice is that there's no island or islands that are completely separated from everything else.
You could turn this into
the one I just highlighted does not connect unless I don't see the whole. Is it connected down here?
Okay, which one? Can you circle the one that you're?
The one I was looking at is this one.
This one right
I
here?
don't see the whole screen. This whole thing is by itself from what I see.
If you go to the 2 on the bottom all the way to the 4, it connects to the whole thing.
Oh, really? There's a line down here? I don't see the line down there.
Yeah, I don't
Okay.
see it either. I don't see the bottom.
Yeah.
Yeah.
Okay.
It kind of reminds me of the tree branches. If the numbers can add up to the next one, then you can draw lines to that and connect them.
Oh, interesting.
You can turn this into a PE activity.
Oh.
PE mixed with math. Do this on the basketball court.
I like it.
It looked like the floor plan at the supermarkets when COVID first started.
Yeah,
That's what I thought when I first
follows.
looked at it.
Okay, so
That's a
you
solve.
you all have stumbled upon all of the rules, basically. Now let me get to a different puzzle for you. And hopefully if I'm sharing the screen correctly, now you're seeing a different bridges puzzle that is not solved. Everybody seeing that?
Yes.
Okay. Now we may not have time to solve this whole thing, but I wanted to give you an idea of what it's like to actually try to solve one of these. So let me go over the rules one more time. So every one of these numbers, that tells you how many bridges must come to that island or leave that island. So when you see a 3, that means that island needs 3 bridges, a total of 3, exactly 3. A 1 means exactly just 1 bridge.
Mm-hmm.
So
Wow.
anyone see a nice starting point?
The 1.
I think one of
Yeah,
your,
the
I
one.
think one of your,
There's only 1, so that's probably where you start.
Okay,
Sure, but
this
where's
bridge
gonna
needs
go?
1 island. How many choices do I have for that bridge?
2,
Either
2
2 or
choices.
3.
2.
You can go to the 2 or the 3.
3.
Go up or it could go over.
It is like a Sudoku problem.
It is.
I'm going to draw your attention to this 3. Can you see my cursor, by the way?
Yep.
Yes.
Okay. So I'd like you to think about what's going on there.
Oh.
That one has to have 1 route connected just one way and then 2 shooting out.
Okay. Was that Dwayne?
Yeah.
Okay. Now, Dwayne, which way do you think the 2 bridges go? Across or down?
Oh, I haven't thought that far ahead, but
Okay, that's okay, because I don't. That was
Down.
kind of a trick question because I don't think we know. But
I
we
think one of
do.
the other things you need to consider, think about is the bridges that won't do like a U-turn or like a angle.
Right.
Like this is not in this. That has happened. That's never going to happen. So those bridges are out. So therefore, you're only left with certain options.
Exactly.
So you know that this is going to be here. You know that that's going to be there.
Right.
Well,
Yeah. So just by using that process of elimination, this is going to be there. This is going to be there. And then the other thing is, if you think about like this section right here, like these sections right here, you know that there's never going to be a T that's
Right.
going to happen there. You know that there's never going to be a T that happens here. So those sections are out as well.
Good.
okay, now Randy, I have a couple questions for you though.
Good.
I think you said there has to be a bridge here.
Yes, there has to be a bridge there because
How do you know?
in the other example we only had horizontal lines and we had vertical lines. We never had an elbow.
What about down here?
Well, so okay, so based off of that, so based on what I just said, this is going to have a line going down. This one is going to have a line going this way and going that way because there's 2 bridges.
Why can't they both?
Which means this is going to.
Can't they both be going?
They could be, yeah, they could be.
Okay.
I mean, that's a possibility.
Or they could both be going across.
Mm-hmm. Correct.
Mm-hmm.
So I'm just pointing out that. Okay, now wait. Now who's writing in red over here?
I am. I'm trying to figure out this 3 right here.
Okay.
Looks good. Except for this.
And then this would go across.
3. It's gonna go somewhere.
Or you could. if we're only limited to 2 roads per.
Or here.
Because they could go back and forth. It's not just on the dotted lines. Because I thought, oh, we're limited to the dotted lines. We can only connect the dots. I remember that the bridges go back and forth. So if we're going to do 3 right here, 2 would go to here, and then maybe 2 again right here. Oh no, it can't because this is a 3. Maybe right here it goes across 2 times. So that builds those 2. I don't know. Got stuck right there.
Right.
Okay.
Do you want me to clear mine or just keep it on there?
Actually, could you clear it just so we can go back and talk
Okay.
about a couple of these? Thank you. So I think Dwayne made a comment first about this 3, that there's going to be 1 bridge going one way and 2 going the other way. But we don't know where the 1 goes and where the 2 goes, correct?
Right.
But what can we conclude from that at the minimum?
That there's going to be 1 line going vertically and 1 going horizontally.
Nice. That's what I wanted you to notice. And then one of these is going to be a double bridge, but right now we don't know which is going to be, I don't think.
Correct.
Right.
Okay, so that is a start. Now,
Okay.
any idea what I noticed about that 3? It had 3 bridges and how many choices? How many directions?
2.
2.
Only 2.
Right.
Oh, we're gonna have 2 bridges.
Right.
Now, one thing that does is it knocks off an option for this 2 up here. Now, let me ask you this. Can I put 2 bridges here?
Yeah.
Good. I'm not sure if
Yes.
it's gonna work though.
Yeah.
Yes, you can because there's 2 on both bubbles.
2 would have to go. 1 would have to come
No.
down.
Yeah, because the 2 and a 3 below, the 3 below 2.
Oh, that's right.
Okay, that's
You
one reason.
can't do a double line there because
Yeah.
then those 2 islands would isolate themselves from all the rest.
No kidding.
Okay.
There's like 100 people here. Can we do this in a breakout session for like 15 minutes?
Okay, I heard that suggestion. Let me just finish that thought that 2 people have argued now that we cannot put both bridges across here for 2 very good reasons. So what does that mean, like for this 2? One of its bridges has to go where?
To the left, to the 3.
Yeah.
2 to 3.
And what does it mean for this 2?
1 goes to the left.
1 goes down.
One of them has
Down, goes down.
To the left.
And
then
it goes across.
I will need, well, will I need 1 here? Not
Yeah.
sure.
Yes.
Maybe both of the bridges go down.
No. Oh,
Could.
you want
2 on
the
top.
top line. Either way.
Okay, now I do want to squeeze in one last very quick activity because I'm almost out of time. But just so I just wanted to give you a taste of this bridges puzzle. This is they're not as easy as they might appear.
I'll post the link to this on the teacher workshop and then you can play with it more.
Good idea.
Okay, thank you, Dave. Let me just, in my couple minutes remaining, bring up a different puzzle. Okay, yet another one from Crazy Dad.
Mhm.
So this is called Futoshiki. Some of you might have seen this when I visited your classroom. It's one of my favorites. How many rows does this puzzle have? 4. How many
4.
columns? Okay, so that tells us we need to use the numbers 1, 2, 3, and 4 to solve this puzzle. No 5s, no 6s, no 0s, just 1, 2, 3, and 4. Someone mentioned Sudoku earlier. This is a lot like Sudoku. You may not repeat any numbers in any rows or columns. So every row has to have a 1, 2, 3, and 4. Same with the column. And these are your familiar inequality signs. You might even see vertical ones, and that just means whatever you put in this cell has to be bigger than this number. This has to be bigger than that. And just one other clarification, it's only about, this relationship is only about this cell and this cell, just the ones that are on each side of the inequality. It doesn't mean that this number has to be bigger than everything in the row. So, any idea what I should put here?
That one can't be a 1. Oh, where did you go?
Correct. In fact, I think that was Dwayne. Let's shift to this column. Where can I put the 1?
Down in the bottom left-hand corner.
Is that the only place the 1 can go?
In that row or in that column.
Okay, nice.
One's got to go here.
Any idea what goes here?
4.
Why?
Because it's got to be bigger than any of these other 3.
Okay, yeah, see this whole chain of numbers right here. So yes, I think that has to be 4. And then
That's 3.
3, 2, 1.
It's going to be a 2.
Right.
Yeah, that's the only way you can satisfy all of those inequalities.
Mm-hmm.
Now we only have one number left up here.
Makes it a 4.
Right. Right. Okay.
Hold on. That top row, are those 3 numbers combined like a hundredths number?
No, good question. They're all individual digits. Individual.
Okay.
Just like a Sudoku puzzle would be. What goes up here?
2.
Could be 2 or
3.
1.
It's got to be a 2.
Because there's a 1 right there.
Oh, bingo. Right.
So that's a
1.
1.
One.
Nice. There we go now.
Okay, we have 3 1s in the puzzle already. Where does the last one have to go?
Under the 3.
Second row, yeah, under the 3.
Good.
And
Right.
3 at the
Both
very
at the
bottom, in the second column.
3 down here.
Second column.
Second column.
Left.
Go down.
Oh, down
By
here.
the
Sorry.
1 right there.
Gotcha. Okay, we have one more 3 to put in here.
2 underneath
Next
the 1.
one up right there.
Yeah.
2,
3.
3.
4.
4.
4.
4 on the other side.
4 and 2.
Yeah. Cool.
Excellent.
We did it. Oh dear, it took us 2 hours.
2 hours?
What kind of time are we in?
Let me just
How
show
old
you
am I
that-
now?
Let me just show you that you can make larger futoshiki puzzles. They get quite challenging, even if you just go up to the 5x5. Now you can use the numbers 1, 2, 3, 4, and 5. You can use this little book down here to pick the size of puzzle you want. They get rather challenging. I've used these with, well, let me ask you, what grade level do you think this would be appropriate for?
6.
High school.
And
Six and higher.
I think it's
Third
all
grade.
ages.
We did in third.
Yeah, I think elementary school could do this.
I was gonna say, I think some of my second graders could figure that out.
Okay.
As long as
And-
they know the rules of greater than and less than, and not having double digits in either the rows or the columns, I think you can have it in, first, second, and up.
I was gonna say that you could use it in first grade, and teach them that easy with the easier puzzle, not the one that's harder, but you could start out with a real easy one.
Well, you could even make your own with only 3 digits to start them out.
Yes, and in fact, I have done that. I would, if I had time, I would write in a couple for you. I would start students with 3x3.
I remember you did this with my students in Kayenta.
Uh-huh.
Yeah, they liked it. They
Yeah,
enjoyed it.
yeah. Okay, I've gone a little overtime, I think. I apologize about that, Dave.
Oh, it's a wonderful session. Thanks, Pam, very much.